Alright, now that we have a new enemy class ready for use, it's time to turn our attention to the behavior of this enemy. We need to start putting together some of the navigational elements that will be used by the enemy inside of our game. In this video, we're going to focus on two things: the behavior itself and a method that will allow us to use the node network in conjunction with arbitrary actors. Since the enemy's behavior is going to use the path node network to perform navigation, but when it's navigating, it's always going to be navigating to an actor rather than an actual path node. So we're going to put together a method that will let us package all of the things that we would otherwise have to repeat in order to fire off a path node-based navigational operation. So we're going to kick this video off with the creation of a method called navigate to actor. Let's scroll down to the bottom of the scene game class, and let's put together this new method. This will be a private method with a void return type, and again the name is going to be navigate to actor. And we will take in an actor parameter called actor. Then inside of this method, we will take into account the fact that as the enemy itself is an actor, it's needing to navigate to a specific actor, so we will find path nodes that are close to the enemy and the destination actor. Then with those path nodes, we can calculate an actual path. Now the first thing to do is to establish the start and goal nodes. So we'll drop down some node variables, beginning with start, and we will simply find the path node closest to the enemy. So our starting node is going to be equal to node.getClosestNode, and we will pass in the enemy's position. Now we need to establish the goal node, so we will say that we will have a node goal, and this node variable will be set to node.getClosestNode for the actor's position. Again, we're passing in a target actor here, so we will drop actor.position into this method. Alright, now these two methods will this method will either return a node that we had found or null if there was no node that could be found. So before we progress, we're going to check and make sure that start and goal are both not null. So we'll say if start is not equal to null and goal is not equal to null, then both of our nodes are valid and we can use them in order to navigate. The next thing we'll do is we will employ our A Pathfinding in order to generate a node path from this start and goal position. To do this, we'll make a variable that is a list of type node. We'll call this list path, and we will set it using A*.findPath. And to the findPath method, we will pass in our start and goal nodes. Now we will do a check on this path once it gets returned to make sure that we did, in fact, find a path. If we had a node network where the paths where two branches were not connected, it's possible that null would represent the fact that no path could be found. So we'll first do a check and make sure that we do have a path. Path is not equal to null. And if this is the case, then we want to tell our enemy, our enemy's navigation, to use the path that was just found. So we will use the enemy nav field, we will invoke the begin navigation method, and pass in our path. So again, the purpose of this method is really just the fact that there are a series of operations and several checks which must be done before navigation can begin with a given behavior. Now at this point in time, we have not yet instantiated the navigation itself, so we would be unable to call the method until we get that enemy nav field set up. So before we run and test, let's turn our attention back to the build scene method, and let's put together the enemy nav behavior. We'll jump in here right before the enemy is created, and we will set our enemy nav field to be equal to a new instance of behavior nav. We need to pass in a weight, so we will give a weight of 0.2f. The next thing we'll do is we will set up a handler for the goal reached event. So we'll say enemy nav.goal reached plus equals tab to bring in our handler, tab again to bring in the method. We're going to need access to the goal reached event, since when we reach the end of the path that we're traveling, the enemy will need to make a decision. Basically, this is the what to do next portion of code. When we reach the end of the path, we need to check and say, are we still wandering? If we are, we need to find a new node to continue wandering to. Or if our state has changed and we reach the end of the path, we may need to do something other than wander. So let's go ahead and code in the first decision for the goal reached event. The first thing we'll do is we'll simply check and see if we are wandering, and if we are, then we will continue to wander. So we'll say if enemy state, or rather enemy dot state, is equal to enemy state dot wander, then we have reached the end of a current path, we are currently wandering, and in order to continue wandering, we will fire off a new navigation operation to a new random node. We'll fire off the navigate to actor method. Now for the actor that we would like to navigate to, we're going to leverage the fact that nodes are actually actors. So we can pass a node into this method. Then when we run get closest node on the node itself, it's going to have a distance of 0 to itself. So it's going to win based on any other node around it. So this way we can pass in a random node. In order to gain a random node, we'll access node.getRandomNode and pass in the random object that we're holding here inside of the game. Then we can close off our two sets of parentheses, and that takes care of firing off a new navigational operation. Now at this point, if we were to run the game, you'll notice that we are still not wandering, and that's due to the fact that we haven't yet added the enemy's navigational behavior. So what we'll do is we'll jump in here right below the enemy's creation. We'll jump in here right after we set the speed, and we'll take our enemy, look at its behavior list, and add a behavior. This will be the enemy nav reference. This is also why we had created the enemy nav first, is to make sure that it was available to be assigned to the enemy's behavior list. Now at this point you might think that we've got the behavior, so everything looks like it should be ready to go, but if we run once again you'll notice that our actor is still not moving. This is because the only place that we are firing off a call to navigate to actor is when we reach the end of a path, when a goal is reached. We're never going to reach the end of a path if we never begin moving. So that means after the scene is created, we need to fire off an initial call to navigate to actor in order to put the enemy into motion. So at the very end of our build scene method, we'll make a call to navigate to actor. We want to navigate to a random actor just as we had done in the wandering state. So I'm actually going to grab the code for selecting a random node, paste that in our navigate to actor column, and that will take care of moving to a random node initially. Now if we build and run, we can see that we get a path calculated, we can see that path highlighted, and we can see that our enemy is traveling to the end of that path. The moment he hits the end, then that goal reached event fires and recalls navigate to actor with a new random node, and the random wandering continues. So we have wandering behavior now established for our enemy. At this point I'm going to make one small tweak to the navigation network drawing. At the moment we had used the brightened lines to make it easier to draw out our path network, but right now that's making it hard to see the difference between our path and an average line. So I'm going to set our line color back to its original value of 80, back in the style class. So here we have the line color field. We'll pull these back down to 80, which will make our lines harder to see, but the lines themselves are less important now. At this point, we're more interested in the paths that get generated. So we bring the game back up, and again, now our paths are darkened and hard to see, but the actual path that gets generated stands out from the background. Alright, we have an enemy that is now in motion. There's one last thing we want to do. Let's put together some debug state drawing. Let's put together a line of code that will always show us the state of the enemy to make it easier to track the state as it changes. So we'll move down here to the draw method. We'll jump in right after we draw the background texture. and we'll put together some code for drawing the enemy's state. We'll begin with a variable. We're going to use some string formatting in order to put this information together. So we'll store this in a variable called text. Text will be equal to the result of string.format. The format string will be the words enemy state followed by the argument 0. That argument is actually going to be enemy.state. Alright, that takes care of our string formatting. Now we can use this text value in order to draw the text to the screen. We'll begin a call to spritebatch.drawString. We'll draw using the large font, so we will grab style.fontlarge. We'll draw the string text. We'll draw this text at the position 10 by 10 offset from the top left of the screen. So this will be a new vector with values 10 by 10. We'll draw this using the color white. Now we also need to gain access to our layer depth to make sure that this text draws on top of the background texture. So that means we'll need to pad out all of the parameters necessary to access layer depth. To do this, we'll set a rotation of 0. We'll set an origin of vector 2.0. We will set a scale of 1. We'll set sprite effects to none. And finally, we will set a layer depth to a value of 1. Alright, with this line put together, let's now jump in, test things out, and we can see that we have an enemy state of wander. Now I'm going to adjust this text just a little bit since it's drawing over to brightly colored nodes, and that makes the text a little bit hard to read. So we can jump in here and set our Y value for the text, possibly to 25. That will move the text below these nodes and simply make it easier to read. Now at the moment, as our enemy navigates, the state stays at wander. This is because we are never experiencing anything that will change the event, or rather change the state for the enemy. But up until now we do have the ability for our enemy to navigate all across the node network. Another interesting thing you see about this network is our enemy respects the locations of the walls. Even though technically they're just background textures, if we watch the enemy, he always navigates in between the walls or into the rooms. So we've already, even with something as simple as wander, established a correct looking scenario for the graphics that are in place. Now with our basic enemy navigation in place, that's going to take care of this video, and it's time to move on.